Let's try to solve a function transformation question. I'll let you pause the screen, take a crack at it, and then once you're ready, we'll solve it together. Okay, so let's get started. So we can see that this is a quadratic equation that's being transformed. So we know that at the end of the day, the function is going to look something like this. Ax minus h squared plus k, where k is how much the function was translated vertically, h is the horizontal, and then a is both the stretch and also what I like to call the orientation. So is it facing up or facing down? So let's look at the graph now and see how many we can solve just visually. So we know that an original quadratic equation looks something like this. It touches the origin and then it goes up. And so we know that this function in red has been transformed slightly. The best way to inspect this is to actually look at the vertex. And so for those of you that may not know or may have forgotten, the vertex is simply this point over here. And so the vertex for the red equation is over here. So that is a good marker to see how the new function is being transformed. So by looking at that, we can observe that the function seems to have been translated 2 units to the left, and then so I'm going to write this 2L, and 3 units down, 3 down. And so we would know that the k value would be -3 and the h value would be -2. So we can put that in. We can say that f of x is equal to a times x minus -2 squared minus 3. So if I were to simplify that, I would get a times x plus 2 squared minus 3. So we're almost done over here. We just need to figure out what this a value is. And for us to do that, we need to pick a point on the red graph that we can see easily. So if you were to look at this red graph, you can notice that this point over here is quite easy to measure, to observe. And that point is 0, -1. So that's the x and the y coordinate, or f of x. So using that value, we can figure out what the value for a is. So I'm going to put those numbers in. I'm going to say -1 is equal to a times x, which is 0, plus 2 squared minus 3. And I'm going to simplify that. This is just, all of this is just 2 squared. So that gives us 4 minus 3. I'm going to bring the 3 over to that side. And so I'm going to get -1 plus 3. It's going to give me 2. 2 is equal to 4a. And so dividing both sides, I get a, dividing both sides by 2 is equal to, dividing both sides by 4, sorry, I get a is equal to half. And so now I have all the missing information that I need. I'm going to put it in over here. I have f of x is equal to half, because that's what my value for a was, x plus 2 squared minus 3. And so this is my almost answer for this question. The reason I'm saying almost answer is because this is still in vertex form. And as the question was asking above, we need to figure out what the equation is in general form. And so recall that the general form looks something like this. So general form looks something like f of x is equal to ax squared plus bx plus c. And so I just need to make this equation look something like this. And it's actually not that hard. I'm just going to take our equation. I'm going to rewrite it over here, is equal to half x plus 2 squared minus 3. And I'm just going to expand it. So the way I expand it is I'm just going to write the bracket out twice, minus 3, and then I'm going to perform some FOIL on this. And you can try to do the FOIL by yourself, but I know by looking at it that it's going to look something like x squared plus 2x, which is plus 4x plus 2 times 2, which is 4 minus 3. And then I'm going to bring the half into all the terms. So I'm going to get half x squared plus 2x plus 2 minus 3. And finally, I'm going to simplify. So I'm going to get half x squared plus 2x minus 1. And so this is the answer right here in general form. So that was it for this video. I hope that you learned something. If you did enjoy the video, thanks for watching. If you had any questions, just put it in the comments below. And I will see you guys in another video. Thank you.